let's pick up at the standard material in the chapter here. So now that was all server-side functionality we were talking about, things like Java and PHP running on the server to process the requests that come in from the client. But you can also add functionality to your browser. Now, HTML is the default functionality of your browser. They can all do this. If they make a HTML request, they make an HTTP request, they get an HTML page and it describes how to draw the page, and they will draw the page from that, the only exception being Lynx. Lynx is a command line browser for Linux that does not have any graphics, it just shows you the raw HTML. But almost everybody else wants to see the page with images and formatted text and stuff. XHTML is a more strict version of HTML that people thought was going to take over 10 years ago. It didn't really. All right, and so you got hyperlinks. If you have an ahref anchor tag, then the text in here gets underlined and it becomes a hyperlink. And when the user clicks on it, it will then make a request getting this page, going to that place at that server. So this is, then you have forms. You can talk about a form. Yeah.
How is XHTML? What's different?
HTML is lets you have opening tags without closing tags and things like that, and it doesn't report errors or worry about it. XHTML has strict rules, and it also complains when you break them. So that's the problem with HTML is there are so many other languages mixed into HTML, like JavaScript and PHP, that it's very hard to parse it, and browsers make mistakes a lot. And coders make mistakes a lot, and so it's not really clear what you want. And often that leads to security problems. So people said, we're going to fix it. We're going to make XHTML that's going to be a strict language like C or Visual Basic where you have to have it right. But that didn't really catch on. People were trying to fix the vagueness of web page design. And if you can have an active form in HTML, you define a form and /form, and in here you have an action. This is the script on the server that it will run. You see this is a PHP script, and it's going to send the data with a get. And here's what it's going to get: a name and a password, which are text fields. And you see name and password are here, and then you have a submit button here. So when the user puts in a name and password and submits, it will send a get request to that script containing those parameters. This is how you collect data from the user in the simplest way, with a form. And so that creates this request. Because I used a GET request, it puts the name and password right here in the query string, which is not a good practice for a password, but you can do it. This is a GET request. This is how the parameters will go to the server. And then the PHP script on the server will be able to run whatever coding you want to based on those parameters. Now here's another thing you can have. You can have POST and encode it as multi-part form data. This is another way to send data. Now you can send a username and password and submit it. And I don't know why this exists, but what it does is it creates this random label, WebKit form boundary, and a bunch of random characters, and then it breaks it up into blobs of data separated by that marker. That's this multi-part form data. That's what it really does. Very strange thing. I've never used it, but some people like it. Then there's cascading style sheets. When they decided to have XHTML, they also wanted to separate form from content. So the idea was you would have XML data, which would just be the data, and then the form would be specified by these style sheets, which a lot of people do use. So then the reason you do that is because then you could have something like a phone app that queries the data, but does not want to present it the same way the original person presents it. And this app, you can present it differently. So you want one way to get the data that's separate than getting the form, whereas in HTML, the two are mixed together. So cascading style sheets specify the format. So the H2 is going to be red print. You specify tags like this in a style sheet, and it doesn't have any data that prints on the page. It just has these styles that will be used to format the data on the page. All right, and JavaScript is huge. It's at the heart of almost all modern web pages. I guess I better shut that door again. They sure like to do a lot of yelling out there. Anyway, this actually is responsible for the modern world. You know, 12 years ago or so, JavaScript was kind of useless because it ran very, very slow in Internet Explorer. So JavaScript was just sort of a stunt where you could change the background color on a page or make little fireworks appear, little silly things like that. But you couldn't do much more because it ran so slowly. And then Firefox and I think Chrome said we could improve the JavaScript engine. So in those browsers, they improved the engine to run 100 times faster. And now suddenly, you could write a whole complicated page in JavaScript and it would move. And so Microsoft was humiliated. They had to improve the JavaScript engine in Internet Explorer and now Edge. And then all these JavaScript-based platforms came out, and it's now the main language used. And you had things like Node.js and all these complicated Angular, all these complicated web design frameworks are all based on JavaScript now. And people do a ton of JavaScript coding, which is quite difficult, I must say. I had to write a whole app in Node.js as one of my consulting gigs, and it's very confusing. JavaScript is a difficult language, but it is very important these days. Anyway, so you can have, now one common use of JavaScript is it runs in your browser to validate data. You can write code that will check to make sure that you're not putting in more than the allowed number of characters in a field or a dollar amount that's odd with allowed range. But the problem is if you verify data on the client side, you don't know that's happened. The client can modify the script in their browser. They can also capture the request after the browser has made it in a product like Burp and modify it. So if you run validation data on the client side, you can't trust it to run. Now, the only point of it is to give the user a better experience. So if you put in not enough characters in your phone number and click submit, your JavaScript can run right on your computer and say, no, you have to fix this. It doesn't even go to the server at all. It checks right on your machine, so you know you got to fix that form. That's useful for user experience. But you can't assume when the request comes to the server that it's going to be properly formatted just because of that script, because you don't know that the user really ran that JavaScript in their browser. And many developers don't understand this. They put script in and they don't really understand whether it's on the client or the server side and which one can be trusted. So anyway, now, JavaScript uses the document object model to refer to objects, which is quite helpful, and I have a picture of that coming up. But by the way, I just mentioned here that Microsoft, of course, had to make their own version of this called VBScript, and it sort of came and went. It's still available in some forms on Windows machines, but it's not really used on the web anymore. Browsers mostly don't support it. But anyway, the document object model works like this. Your document is an object, then you have the root element, which is HTML, then you have other elements like body and anchor tags and header and so on. By this cascading tree of objects that contain other objects, you can refer to every object on the page. So, if you wanted to make a page that just says Hello World, instead of literally putting the text Hello World there, you can define an object. Here's a paragraph with a name of demo. And now here's a script in JavaScript which get element by ID of demo and change its inner HTML to Hello World. This is how you refer to an object on the page and calculate what goes there with JavaScript. So you'll see a lot more of this as we get into the Web Security Academy projects. All right, and then there's asynchronous JavaScript and XML. In the early days, you would just load a page. And if you want to load it, if you want to change anything, you have to reload the whole page. And that was the Web 1.0. That's, of course, not good enough anymore. Consider something like Google Maps. You can have a whole map, and then you can grab it and drag it down. And when you do that, this part will refresh with new data, and the rest will not. So it doesn't reload the whole page when you drag it down. It reloads just a little bit up here. And so it's doing that with a whole series of requests. You can see them in Wireshark. Little requests here, getting a maps, and with these complicated parameters, PB, all these parameters telling it exactly what coordinates. I want the little bit of map up here, just to give me the next little bit of this page. A separate request for each one, so it doesn't need to reload the whole page. It just gets the little bit it needs while you drag it. That's what Ajax can do. JavaScript and XML together can be used to fetch little pieces of data in a controlled way instead of having to reload the whole page. And it's necessary for the modern user experience. And so another way to organize your data other than XML is JSON. This is JavaScript object notation, and all it is, you put it in curly braces, and then you have name, colon, value, with commas separating them. So any kind of data could be in any format, but this is JavaScript object notation. All right, and so you can update data with JSON. You set a contact equal to this object in JSON, and send a post up. And it'll have a submit flag you'll update, so this will just send JSON formatted data to the server, which will then add it to a database or change somebody's phone number or whatever you're trying to do here. Now, the same origin policy is at the heart of most browser security. A browser is supposed to know what domain you're on and what kind of data to be sent. So if you're sending cookies, you should only send them to the same domain, not to some other domain. And if you're accessing scripts or something from another, or resources from another server, you should only accept it from the allowed domains. So Facebook can't read or write to data on your banking page, and so on. That's the idea. And many attacks rely on confusing this with cross-site scripting, cross-site request forgery, and other attacks where you manage to get code to run in context where it shouldn't run. That's the cross-site part. You get code on one site to run on a different site. And that's when the same origin policy has failed. And we'll see quite a few of those attacks as we go ahead. So a page on one domain can make a request to another domain, but it can't process the data returned from that request. A page residing on one domain can load a script from another domain. And a page cannot read or modify the cookies belonging to another domain. So these are some of the rules of the same origin policy. And as we'll see, there are ways to break these rules when there are vulnerabilities, which there often are. Yeah?
I was trying to visualize what is, if you go back to the last slide, where it says cross-site scripting, right?
Yeah.
In my mind, I thought it was like the cartoon, the Roadrunner and Coyote. I don't remember that cartoon where there was like a painted up wall and like they ran through it.
Well,
is it like that where someone just frames the website and they can put in the information? No,
I think that's actually closer to UI redress we'll talk about. But cross-site scripting, for the simplest case of cross-site scripting, goes like this. If I have a page where I can post something like Facebook, and I can put like a message, I could put script tags in the message. So if this happened to MySpace, for example. MySpace was a precursor to Facebook. So you could put up a message like, "Hi, I'm Sam." And then you put in this message, scripts. And then do something like, put in code here that will do something awful, like send your cookies to me. So I can log in as you. And I can put up that thing as my message. And now anybody that views my page, this script will run in their browser. Now that script did not come from the developers of Facebook. It came from a user. So I put script up even though I am not the administrator and I don't have the authority to put script on the server. But because they didn't sanitize their input, I was able to put script tags in a message which is then displayed to other users. So a script that originated from my machine is running on your machine when you only thought you were talking to Facebook. So I've now tricked that page into having code that did not come from Facebook. This is one simple example of it. And so to prevent it, you have to take all the user input and sanitize it. Don't let them put in tags like this. Or another way to do it is when you take any user input, you URL encode it. You do not print characters like that. Instead, you encode them like this, &GT semicolon. That is the HTML code for a less than sign. That's a less than sign. And so if you do this, then it will just print that on the screen, but it will not interpret it as a tag in the browser. So these are the main defenses. You sanitize data on the output is the best thing to do. Encode the data when you print it out so that all the control characters are turned into visual representations that no longer have the special meaning. But in order for that to work, you have to know what languages are in use. And that's where it gets really hard, because different languages have different control characters. Can you use JavaScript to prevent it? I'm not sure. We'll talk about some defenses. Yeah, you can prevent it at many places. You can prevent it by user input. When the data comes in from the user, you can scrub it for dangerous things like this and remove them. That's called sanitizing. When you send the data out to the next user, you can sanitize it on the way out, removing all the dangerous characters. That's actually called output encoding, and that's much better. And there are other techniques too, which we'll talk about, such as if you want to protect a cookie, you can specify cookie to be HTTP only, which means it will never be accessed by JavaScript, but only by HTTP, and that will prevent people from stealing it with injected JavaScript. And we'll talk, there are a lot of other defenses, but yeah, these are very good questions. All right, so, yeah, all right.
I would say that's perfect. Thanks for
Okay, good. All right, good. No, I'm glad you're asking questions. It helps. And someone said, what's the difference between CSRF and cross-site scripting? We'll get into it later, but cross-site request forgery is where you make a request appear to come from a different source. So if I get you to open my Facebook page, I can make a request that goes over on an Amazon tab and buys my book without you knowing it. I trick it into making a request that appears to come from the wrong source. And one way to do that, one simple way to understand, is when I steal cookies. If I'm in a wireless network and you go to an unencrypted page, your browser sends a cookie and I can see it. So I can steal your cookie. Now I can log in as you with your cookie. That's one form of cross-site request forgery. But the general point here is instead of putting script that runs out of the right context, I make a request which appears to come from the wrong place, which appears to come from you, but it really came from me. And so they're quite similar, but there's some subtle differences. Right, and I see some more. A guy that did something similar on MySpace, right, that's right. That was the original Sammy Kamkar, a famous hacker. He made the first MySpace worm. He put code on his MySpace page. Everybody that viewed it, they would add him to their friends list and immediately repeat this attack to everybody else. So in like 2 hours, he had more friends than anybody. He got like 5 million friends in 1 hour because everybody automatically friended him. And that was proved the power of a cross-site scripting attack. And one reason why people don't care about this largely is one thing that did not happen is it did not compromise code on the server. He didn't take over the server or steal any data from the server. He just bounced an attack off the server that attacked the other customers. So if you don't prevent cross-site scripting, your server can be abused to hurt your customers, but they don't actually get into your server. So most companies don't regard this as a data breach, and they don't take it very seriously preventing it. So most websites do have cross-site scripting vulnerabilities, because people just don't put a lot of effort into stopping it. Anyway, these are very good questions. So HTML5 is a new one. It's all over the place now. And the point of HTML5 was to add more features in it so you would no longer need extensions like Flash and stuff in your browser to play videos and things. So it has new tags and APIs that makes it possible. You can even has the ability to store a database in your browser. I've never used this, but in principle, you can store data. Yeah.
When did HTML5 come out?
Oh, I think at least 8 or 10 years ago now. Yes, I think.
8 or 10 years ago, Flash just vanished.
Yeah, well, Flash mostly vanished because Apple refused to put it on the iPhone.
Oh, it's 10 years ago?
Because what?
Flash vanished 10 years ago.
Yeah, Flash began to go out because of Steve Jobs. Steve Jobs refused to support Flash on the iPhone. So then if you put a Flash page, people with iPhones couldn't see it. And the iPhone was so popular that it never recovered from that blow. But also, it had a lot of security problems and so on. And so HTML5 kind of replaced it. So HTML1, you just had static pages, or Web 1. Web 2 is where you had all these asynchronous AJAX doing things and cross-domain integration and new technologies like we've been talking about here. So you had more complicated pages like Google Maps and Facebook and Amazon. That's Web 2. And a lot of this depended on browser extensions that you'd have to install in your browser, like media players and such, Java, ActiveX, Flash, Silverlight, and all this jazz. There were a lot of these, and they were very common maybe 10 years ago, and they sort of fell into disfavor. Very few people use them anymore. They certainly had a lot of security problems. And nowadays, your default browser has all the functionality you need. You don't usually have to add any plugins to do anything. So, stateless HTTP is intrinsically stateless. You have one request, you have one response, and that's it. No part of this remembers anything. So I say Netscape invented the concept of cookies. And so now you add stateful data to supplement this. So the request has things like cookies. And so on the server, you have a database that is a session that knows that you have logged in, who you are, and what to show you. Keep track of the cookies in the current session. So now, if you make a request to the server and you have logged in, you'll get one response. And if you have not logged in, the same request will give you a different response because it knows on the server who has logged in. And if it sees a cookie that's logged in, it knows who you are and gives you one bit of data. But if you haven't logged in, it'll show you a different page, like please log in or something like that. So you'll have information in the session containing stuff like items added to a shopping cart and whatever else you've been doing, and you'll have some state data stored on the client. Cookies and hidden form fields, and some shopping sites store all your purchases on the client until you hit the buy button to save processing time on the server. So that's the session. And session management is another origin of a ton of vulnerabilities, keeping track of who you are and whether you've logged in and what you've done. And if I can somehow confuse the session management, I can trick it into thinking I'm the administrator when I'm not, or that I'm somebody else when I shouldn't be. So this session management is another area of weakness. Yeah?
Session storing database?
Sessions what?
Storing database.
Yeah, it's stored somehow in the server. I'm not exactly sure where, but I think the most logical thing would be to put it in a database. Yeah, it's a good question. I don't quite know how the session is maintained on the server. It'd be good to know. So then we talked about encoding schemes. We talked about it briefly. So this is the main one you do. And let me just demonstrate this. This is pretty interesting. If you go to a browser, like up here, I have NCL. If I put a space in NCL, N space CL up there, I zoom in, and then I press enter. Oh, it didn't stay. All right, let me go, let's just change this completely. Foo, Fred, space, tree.htm. Okay, Fred space tree.htm. It changed it into Fred %20 tree. You see what I mean? The space turned into a %20. That is called URL encoding. Every special character can be encoded by this kind of number. This is the ASCII table. If you don't know the ASCII table, you can Google it. This is an important fact to know. Every character is encoded as a single byte, every English character. So the first bunch of them are weird things like start of text and a bell and a backspace. These are control characters. When you get down to 32 is where the normal things start. Space, exclamation point, quote, and then you have numbers and punctuation marks, and then you have capital letters, then you have lowercase letters, and the largest one is 127, which is delete again. So the printable characters go to 126. From 32 to 126 are the normal printable characters you'll see on your keyboard. And all the ones outside that range are unprintable characters that do special things. So if you try to move a non-printable character, you have to URL encode it, and you can't type it directly on the keyboard. So this is URL encoding. So 3D is an equal sign, 25 is %, 20 is a space, 0A is a new line, and 00 is a null byte. And you can send all those characters to a server by URL encoding them. And then the server will understand it at the other end, decoding it. And the plus character, by the way, stands for a space. Now, when you're attacking web applications, these are the characters it's recommended to URL encode. These are the characters that will usually make trouble. Space, %, pound, and so on. You should URL encode any of these when you insert them as data into a request to make sure that they get into the server without being misunderstood. Because the pound sign, for example, is a fragment character, which we'll talk more about later. But if you go to my page, in fact, I think if we go to the 129S page, this should work. There's 129S. If you click projects, notice the URL here. It is Sam's class. It has a pound projects. This is called a fragment. The pound sign in a URL refers to a location on the page. It vertically scrolls down to that location. This is marked with an anchor tag as the space where projects start. So if you were to try to insert this somewhere in a request, it would be misunderstood as a control character on the server to define a fragment. So if you actually wanted to send that character literally, you'd have to encode it. And that would be here. You'd find the right ASCII code and you have to encode it. All right. Now the problem with this is this only works for English. It's an old system, ASCII, but there's of course Chinese and Japanese and Arabic and Russian and all these other alphabets. So the first attempt to fix that, which is the one Microsoft started using in 1993, was this 16-bit Unicode encoding, where you'd have not 1 byte, 2 hex characters, you have 2 bytes, 16 bits. Now instead of having only 256 possible characters, you have 65,000. Now that is not really enough, by the way. I think classical Chinese has more than 60,000 characters in it all by itself, and so does Japanese. So it's not really enough for everything, but it is enough for the simplified versions of all languages that are used in commercial applications. But this is what Microsoft Windows uses, 16-bit encoding, and you do it with %U. And so you now can put in characters like with an accent mark and stuff to do European languages. But if you really want to do all the world's languages, you use the modern system of UTF-8. And this can use up to 4 bytes. So it can handle up to 4 billion characters. Now you can fully encode any character in any language. This is what's used. So you put a % and 2 hexadecimal characters and another. And so a copyright symbol is this one, and not equals is that one, 3 bytes long, and some of them are 4 bytes long. There's so many of these. Now you can have a computer representation of any character in any language. That's the modern system, UTF-8. And the point of this is, if you try to block a character, like we talked about before, if you wanted to stop cross-site scripting attacks, like the ones we looked at here, you would want to block this script tag. So you might say, I want to prevent the user from sending this less than tag up. But the problem is they could encode that less than tag many ways. They could URL encode it, or they could encode it as Unicode, or they could encode it as UTF-8, and it would look different. So you'd have to consider all these possibilities when trying to stop that character from going up. All right, and then there's base 64 encoding. Now, if you go to this ASCII table, let me just demonstrate one of these. Here's the ASCII table. So A is 65 in base 10, or 41 in hexadecimal. So a capital A is 65, so you can write that in binary. So a capital A is 65, which is 64 plus 1. And if you know your binary, it's 0, 1, 0, 0, 0, 0, 0, 0. Because the way you read binary is you count from the right. This is the number of 1s, 2s, 4s, 8s, 16, 32, 64, 128. So this is 64. And if I put a 1 here, now it's 65. So that's a capital A. So if I wanted to send the message AAA, that would take 3 bytes. So if I run these together, that's the first A. There. That's the message AAA in binary. Okay, and this is normal binary where you use 8 bits to encode a character. In base 64, you take that same message and you choose to break it up into groups of 6 bits. So you go 1, 2, 3, 4, 5, 6. There. You break it up into 4 characters of only 6 bits each. And there's only a total of 64 possible combinations of these. So this is another way to encode data. And the point of this is it takes unprintable characters and everything is now printable. So that uses this character set. You use capital letters, lowercase letters, numbers, and then 2 symbols. Because there's 26 letters, and another 26 is 52, and 10 digits is 62, 63, 64. So now, one of those characters can encode 6 bits. So 3 ASCII characters turn into 4 hexadecimal characters. And the original purpose of this was to send images in email, because email can only send ASCII characters. If you want to send anything else, you have to encode it as ASCII characters. And this is a way to use ASCII characters to encode things. So let me just bring up an example here, base 64, encode. All right, so there's a bunch of online sites that will do it. You can also do it in any programming language you like. So if you go here, I can put in hello and then encode it. Okay, so hello turns into that in base 64, SEVMTE8 equals. That's what you get. The equals is a special mark at the end indicating that it wasn't in integral multiple of 3 characters. So if I do hello with 2 O's and then encode that, now I won't get the equals. But if these 4 characters are HEL, and these 4 characters encode LOO. So people first thought this is like a form of encryption. You can take stuff and turn it into an unreadable form, but you can just reverse it. It's not encryption, it's not hidden, it's just encoded differently, 6 bits for a character instead of 8 bits per character. So you can reverse it, and of course the same website will let you do that. If you go to decode, then you can paste in that stuff and decode it, and you'll get back to the hello. So anyway, this is just another way to make it look strange, but it's another way to move the same kind of data up. All right, and another thing you could do is you could just hex encode the characters. Remember, the A is 65, but in hexadecimal, that's 41, 4 16s plus 1. So 41 is A, 42 is B, 43 is C, so ABC could be hex encoded as this sequence of characters, where you use 2 characters to represent the hexadecimal number for the number that corresponds to the character. So it's another common way you encode data. So there's other things. There's client-side code that can use server-side APIs in these technologies. I don't know how commonly they're used anymore. Silverlight's pretty much gone, but maybe used in Java, where your client-side code can do requests to server-side APIs. And you certainly see that in phone apps. But anyway, all right, let's do the last Kahoot, and then I can go into the demonstrations here. I get back to our Kahoots, which are here, and this is it, 3D. Yeah, I see somebody said Sammy is your hero. Yeah, Sammy did a lot of cool hacks, but he also got in a lot of legal trouble. So, you know, if you're going to do things like that, you need a good lawyer. I've got a lawyer in case you need one. It tends to come up in security research. Even when you're very careful, you end up in some legal hot water in this business. I went to B-Sides, Las Vegas, and there was a talk by the head of cybercrime at the FBI, and he said, "We know that everything you guys do is illegal, but don't worry, we only prosecute the bad guys. We have prosecutorial discretion." So that's not as comforting as I wanted it to be, but that's where we're at. Heard a couple podcasts from a new book that just came out that's all the rage, talking about why Trump and Weinstein and all the powerful people get away with everything. That's the same issue. They can choose not to prosecute you, and therefore you can bring all kinds of pressure on people not to do it. So if you're rich and powerful, you can get away with a lot. Turns out the FBI hacked the ransom group Hive. Yes, over the past year. Yep, they were in control of their servers for 6 months, and they were stealing the keys and giving it to their victims so they could decrypt their stuff. They just came out and announced all that. Yeah. There are a lot of cybersecurity lawyers. There are some, and you can find them through the Electronic Frontier Foundation. And I think there's more and more people in cybersecurity and law. It's a growing field, both for hackers and for companies and everybody else. There's so much cybercrime and cyber attacks that law is a big part of it now. You need a lawyer to find your way through it. So there's a lot of them. All right, so what system defines formats like that? That's cascading style sheets. That's what that is. Yes, someone said it takes too long to become a lawyer. It certainly does. And so lawyers that also know cybersecurity have studied a lot more than most, but they're very valuable. So cybersecurity plus something else is a very good career. Cybersecurity plus business, cybersecurity plus law, cybersecurity plus communications, writing and things like that. That's a very good thing. What's that?
Plus crime.
To plot crimes?
Crime.
Well, for crime, that's true, but you don't usually bother to get degrees for crime. That's usually what you do because you didn't get a degree. Anyway, so which one of these is obsolete? Yep, VBScript is no longer used by any modern browsers. All right, what system requests data from the server without getting the whole page? A small bit of data. Cybersecurity and AI, yeah, absolutely. That's going to be a hot one. AI is the hot thing right now. Yep, that's Ajax. All right, and what system writes a space like that? HTML encoding, that's what that is, non-breaking space. All right. V, all right, good. And Hector. All right, good, I got the winner. Let's have 6 then. All right, well, you've been here for an hour. Let's take a 10-minute break. We'll pick up at 7:25, and I'll demonstrate a project. I want to demonstrate the SQL injection anyway, and then I think I'll just answer questions, including somebody has questions about Burp, which is fine. So we'll be back in 10 minutes. Yeah.
When we do the sanitizing, do we use the regular expression?
Yeah, that's one way it's commonly done.
That's the one way?
There's a lot of ways to do it, but that's one way, yeah.
Like, what's another way?
You can use substitution commands to fix characters one by one.
Oh.
The thing about regular expressions is they can be really expensive to run. You can write a regular expression that takes a lot of processor time. And in fact, regular expressions sometimes have vulnerabilities. So sometimes you have to do something simpler to avoid wasting a lot of processing time on the server.
Is that based on your programming language?
Yeah, to some extent, yeah. That's why, and one issue is Snort. Snort filters traffic, looking for malicious traffic. And you can put regular expressions in the Snort rule, and people that... Snort is a intrusion detection system that watches incoming packets and to decide if they're malicious. And you have a rule that it uses to identify the malicious traffic. And the rules are often written as regular expressions, but if you don't write them very carefully, they consume so much CPU on the server that they can't keep up with the traffic. So you have to be careful with regular expressions.
Why do you consume much CPU?
It's very easy to write because a regular expression can require the server to go through an incredible amount of work. I mean, a typical one will say, look for a letter, then look for 3 numbers, then look for any number of characters here, then look for another number over here. And if you think about what it has to do to match that, it has to take any possible starting position in the stream of data, and then check looking forward very far to see if it matches the pattern, and then go to the next character and try again. What's that?
Mapping?
Yeah, it can be very expensive to evaluate a regular expression.
Okay.
That's the problem. I mean, they're powerful, but you have to be careful. It's easy to write regular expressions that are in fact extremely wasteful of CPU, and they can even have vulnerabilities where a malformed packet will freeze the server because it gets stuck in an endless loop checking it.
Okay.
Anyway, I'll be back in a minute. Wonder if I remember to turn off the recording. Nope, all right.